Hi everyone, my name is Martin. I am an IT consultant and Agile coach. Today we are going to talk about the role of the Technical Scrum Master. A common question I hear is, should the Scrum Master know technology or have a technical background? Many Scrum Masters, especially those without a tech background, says no, because the Scrum Guide doesn't explicitly require it. And this is true, nowhere does it say a Scrum Master has to be technical. But if you look deeper into Scrum values like trust, you will start to see why it really does matter. From my experience and the consultation I've done, developers tend to trust a Scrum Master more when that person understands their daily challenges. They don't have to explain the basics, and they see you as one of them. And when that happens, collaboration changes completely. In this video, I will show you what it means to be Technical Scrum Master, what kind of competencies are worth developing, and why it truly pays off, both for you and your team. We will cover those topics at the high level, but if something sparks your interest, nothing's stopping you from diving deeper. Open a browser, grab a book, or ask a teammates. The important thing is to stay curious and try to understand the technical language your team is using. But first, don't forget to hit the thumbs up and subscribe button so you don't miss any new content. Let's jump in! Let's start with the technical basics. A technical Scrum Master doesn't have to be a developer, tester, network engineer, or DevOps expert, but they should understand the language of those roles. We will go through a few examples so you get the gist of what I'm talking about. Here are some frequently mentioned terms with short explanations. This is a kind of the essential minimum. Branch. Separate line of development from the main codebase, where developers can work on the feature without affecting the main version. Commit. A record of changes made to the code, saved in the repository with a description of what was changed. Merge. Combining changes from the one branch to another, for example, merging a feature branch into the main branch. Pull request. Created by a developer when changes are ready for review and merging into the main branch. Merge conflict happens when two people change the same code and it needs to be resolved manually. Rollback. Reverting a deployment of change if something goes wrong. Pipeline. An automated series of steps, test, build, deployment, triggered by code changes. API. A way of applications communicate with each other, for example, front-end and back-end. Now let's talk about environments and some key related terms. Production. The live environment when real users use the application. Dev environment. For developers to build and test code. UAT. When the product owner or client confirms everything works as expected. Depending on company, the setup might vary. What matters is that you understand the purpose of each environment. This helps with sprint review, readiness, and deployment coordination. It also explains things like it's working, but not in the production yet. Let's move on to CI/CD, continuous integration and continuous delivery, which is the industry standard today. As a Scrum Master, it is useful to understand how the deployment pipeline works, what CI/CD tools do, what the deployment flow looks like from commit to production. This lets you understand when something can be released, what's blocking the team, and how to communicate effectively with DevOps and QA. Now let's focus on practices that influence code quality and team performance. You don't need to use them yourself, but understanding them or knowing these terms help you support the team effectively. Here are some examples that can be distinguished. Clean code. Writing code that's readable, simple, and easy to maintain. Solid. 5 object-oriented design principles for stable, extensible code. Refactoring. Improving code structure without changing its behavior. Pair programming. 2 people coding together, one writing and one reviewing. Test-driven development. Writing test first, then the code, to improve design and reduce bugs. Feature tagging, turning features on or off without code changes. Trunk-based development. Everyone works on the single main branch, with frequent integrations for safer releases. Code review. Having another developer review your code to catch issues and share knowledge. You are not expected to do reviews or refactoring, but when you understand why the team needs time for it, you can protect team from pressure and help prioritize properly. Now let's jump to something many Scrum Masters overlook: technical debt. It's not just bad code. It includes specific issues that affect delivery speed, product quality, and team morale. Examples? Unresolved defects. Known bugs that sit in the backlog for weeks. Devs know about them, but no one prioritizes them. Code debt. Code that's so complicated, so no one wants to touch it for fear of breaking something. No automated tests. Tests must be run manually, deployments done by feel. Risky and inefficient. Hard-coded values, data like API keys, server addresses, or company names written directly in the code instead of configuration files. This can lead to serious issues. As a technical Scrum Master, you are not fixing this yourself, but you should understand them, recognize them, and help the team plan time to address them. For example, during refactoring or by including them in the definition of done. The better you understand these issues, the better you can support your team. And that's the whole point. Let's go through a list of tools that you should at least be familiar with. Must-have backlog management tools like Jira or Azure boards. Optional but recommended: version control, GitHub, GitLab, Bitbucket. CI/CD, Jenkins, GitHub Actions, CycleCI, Azure DevOps. Containers, Docker, Kubernetes. Code quality and security: SonarQube, Snyk. API testing: Postman, SOAP UI, Swagger. IDs: Visual Studio Code, IntelliJ. Monitoring: Grafana, Datadog, New Relic. Cloud: Amazon Web Services, Azure, Google Cloud. Best: get to know the tools your team uses and what they are for. Ideally, even explore their interfaces. Next will be useful technical skills. Sometimes developers share their screen and walk through code during a meeting. It's great if you can follow along, at least roughly. So it's helpful to understand basic of programming, for example, programming in JavaScript, Python, Java on C#. Working with database, for example, SQL basics, DevOps basics, CI/CD pipelines, containerization, system architecture, microservices versus monoliths, API gateways, load balancers, automated testing, unit, integrations, end-to-end tests. So let's wrap up. Do you have to be technical as a Scrum Master? No. But if it's worth it? Absolutely. Because it helps you understand the developer's work better, earn the team's trust, actually help solve real problems, better understand issues raised during retrospective, collaborate more effectively with DevOps, QA and product owners, and most importantly, you become a real valuable part of the team, not just the person who runs the ceremonies. Okay, that would be it. Don't forget to subscribe this channel and leave a thumbs up. Leave a comment with your thoughts or share what technical skills you think help most in the Scrum Master role. See you in the next video, folks.